Thanks for joining us today for this DELMIA Industrial Engineering for Factory Virtual Twin webinar. Thank you for your interest. We will wait a few seconds for everyone to join, and we will start shortly. So today I am with Cyrille FROISSART, who is DELMIA Industry Process Consultant Director, and Julien THÉVENON, DELMIA Industry Process Consultant Senior Manager, who will present you this DELMIA Industrial Engineering webinar. You can see that you can see their email address, so if you have any questions after the webinar, feel free to contact them directly. This webinar will be available in replay on our process engineering, virtual factory and robotics, and our fabrication user community. We will send you an email when the replay is available. I think we can start. Enjoy the webinar. Cyrille, the floor is yours.
Thank you, Romain. I hope you can hear me all. So here is the topics we will cover today with this webinar. Happy to present you the DELMIA solution for the virtual factory, an important topic this day. So during this presentation, I will start by explaining what is the DELMIA solution for the specific domain of what we call industrial engineering, and then which is just a part of the global DELMIA solution. And then we will I will present you the solution for what we call the virtual factory domain, so layout and simulation, so meaning flow simulation, discrete event simulation, and also equipment simulation. Then Julien will explain what we do in robotics and equipment simulation, also covering the virtual commissioning topic. And at the end, I will conclude with a solution we have in DELMIA for ergonomics to simulate manual operation and see machining. And we have a testimony from a customer at the end. So actually, the DELMIA solution is quite large. So let's start by explaining what do we call industrial engineering. So actually, in the DELMIA solution is part of the Tree Experience platform provided by Dassault Systèmes, which is quite famous for our CATIA solution, etc. But the DELMIA solution is a solution dedicated to manufacturing and, globally speaking, to operation. And so we have some solution like Quinticam and Hortense for the scheduling. We have some solution for the execution at the shop floor with Apriso, and we have also all this of the solution for the process manufacturing engineering. Sorry, so the manufacturing engineering, typically the user, the people are working to prepare everything for the production. So between the design office and the shop floor. So we have a set of solutions to what we call process engineering. It's a set of solutions to define the emblem, the work plan, and the work construction. But today we focus on another set of solutions, which is what we call DELMIA Industrial Engineering. So actually what we call virtual factory, meaning mainly layout and discrete event simulation, robotics, fabrication, meaning machining and additive, and we have also some ergonomic solution. So let's start now with this virtual factory solution. So here we have different solutions. Actually, we see that in the past we used to call this domain digital manufacturing, and now we prefer the wording of operation because it's actually larger. We also want to simulate, for example, warehouse. So it's not only pure manufacturing. And here's a different topic that we cover with the DELMIA solution. So again, the virtual twin, we create the factory in 3D. We simulate the factory in production. We simulate the manual operation. We simulate the robotic and equipment simulation. We simulate the NC machine and the 3D printer. And before to go in, we prepare everything. We prepare the program. And before to go in production, we test everything. This is what we call virtual commissioning. So the advantage of this solution, it's all these solutions are connected because they are all based on the same 3D experience platform. We are using a database as a 3D experience, and all the applications are using the same data set, but for different users. There will be someone in the company with some strong focus and skill on the layout and the building, etc. So someone will create the factory in 3D and using some probably some CATIA or other SolidWorks or other CAD software. We can then there will be someone taking this data, but now doing a simulation in a dedicated DELMIA application. Then another user probably will add the robotic or the NC machine simulation and programming. And then after we can do the virtual commissioning before to go in production. That's an advantage. It's always using the same data set on the same on the one data set in the database to be used by different user, just switching between application, but no more dedicated application and no more data set specific to be recreated in each application. So let's do a focus on the first set of application where we create actually the factory in 3D. So what we see in the video is typically we start from a 2D drawing. Here we see a 3D experience platform and we see the name of the application we use here, Panteo Design. So in this application, I start from a 2D drawing that I import typically from DXF or DWG. And on top of this 2D, I can position my 3D devices coming from my library of robots, for example, but also coming from other CAD source if I have the 3D model of the equipment. And I can also use some specific I can also use some specific beam format like IFC. And here also important capacity because we don't start always from scratch. We also have some existing factory, and now more and more we have a point cloud. So we have a capability to import point cloud in any format like E57. And in this case, we can do a simulation actually where we can merge, we can actually simulate a mix between real 3D and point cloud. For example, we have what you see on the screen here is we can remove a part of the point cloud, and I will after check if I replace this existing machine by a new one where I just have the 3D, I can simulate the new process. Okay, so now let's go to now my factory is there. The building, the machine are in the correct position. Let's start to do a first simulation. I want to simulate my factory not only statically but actually in production. So now I'm using a new application, factory flow simulation. But again, the advantage of the platform is I just switch from the plant layout to the factory flow application, but always in the same session. No need to start another software to create a new data set. I'm just reusing the previous data set, but adding some new information because I am now an expert in flow simulation, and I add the information that I need. For example, the source, the sink, the time, the distribution time, and I can do some analysis with some KPI. So when I run my simulation, during the simulation, I have some KPI, such as the time spent on each machine, on the storage, the amount of product in my buffer, etc. The number of parts I can produce, and I want to check if I can reach my production target. So here, for example, we see that on this machine is busy when it's green. When it's blue, it means it's waiting. Here on this robot, I think that there was a failure with the red color. So it's a very nice way to understand where is the bottleneck, where is the problem on my factory. And with the global view here, I'm not very interested in what's actually happening at each station. I'm more interested in the global view of the factory and understand if I will be able to produce my product with the performance I want. And here I want to see what I can see in this diagram, what's happening along the time on all the stations in my line. and with the color code. So yellow, it's waiting, green, it's working, etc. So let's continue the simulation. Again, here another KPI where I see station by station in my LAN what is the activity. I see that, for example, here it's waiting. Again, green is busy. And at the end of the simulation, what is very important, what is actually the goal of the simulation, is to get this report. Because the simulation in 3D is nice to understand what's happening, but at the end here I have all the number, so I can check that I have produced the number of product I want after, let's say, 1 hour, 1 day, 1 week, 1 month. We can simulate. This is the advantage of the simulation. We can simulate 1 month of production in a few minutes. Okay, so actually here we see what we some capability also we have around the logistics, so we can simulate the assembly lines, but not only, we can also simulate all the logistics. So we can define the route for the AGV or the AMR. And we see that we have also some capability, like we see here, to define some advanced parameter for the AGV. For example, we can define the charging status, and I can anticipate some problem with my AGV, that I need to charge again my AGV. My AGV is not, or MR is not available anymore. So this is because the simulation has to be realistic. So here it will be a way to do my sizing. I want to have 10 AGV in my factory. Is it enough or no? Do I need to have more AGV or more AMR? How many robots? How many machines? How many workers? So I want to prepare everything and to check that before to go in production, I will reach the production I want, taking into account also some failure. I can define some failure and with some MTBF, and check that even if I have some problem or some rework in my line, I will be able to reach my production. So now let's go to the next one. So here it's a more complex use case where we have typically an OEM doing with 3 assembly line, doing assembly of appliance, and here we have a supplier providing some parts. So we can define the sequence of operation to be the sequence of product to be produced on a specific stations. Here I have 5 different products to produce, and I can define in which order I want to produce. And then I apply this plan, production demand plan, PDP, and I check. I check that I can reach effectively if I simulate this plan. What's happened? Let's start the production. I have defined now the production demand plan, and I run my simulation. So here the supplier will produce some parts that will be delivered to the main factory assembly line at the OEM, and here it's a pure push mode production. So the supplier will push and produce parts, and the part will be used then in the final assembly line. And we start to see that here at some point the line will be we fill the line, and the storage at the beginning of the line will be full, and of course the supplier will produce parts, and so we have some problem to consume all the parts. So after we see that here we have some buffer that with a high number of product, and we understand quickly that it's not a very good solution because we have a big amount of parts in the buffer, and so we have also now the capability to simulate the pull mode. So we'll see that if we switch from push mode to pull mode, we can still produce the same amount of final product, but with reducing the number of parts in the buffer. So here we see that we have some result at the end of the line. We have 3 assembly lines. So we see here the number of products we have produced after some time. And here it's really the goal of the production is to simulate if I can reach my production. For now, I see that I have a lot of parts in my buffer, and here I see that I've produced, for example, 50 parts after 1 hour and 40 minutes. So I will skip the next video where we see how to fix this issue with a Kanban approach. Another video where we see actually, so here this is interesting. I create a source and then I will create the flow of the product that will go in my line. So on the source, I will define which product. So here it's a bottle. So I will define that I will produce this source will produce a bottle at some time with every 10 seconds, or I can also define a time distribution like normal, low, or any distribution time I want. So now I have defined the line and I run the simulation. Here we have the play button. We have everywhere in the TWIX platform. So at the station, so we have produce the part, the source will produce the part, then we have the station. So at the station, we say, okay, we have a transform activity. At this station, I will take like a certain number of bottles, and the output will be the bottle plus packaging. So this is a packaging machine, and this activity will take some time. By default, 10 seconds, I can change the distribution time if I want. So I do that on all the stations. And then I can run my simulation and check what's happening, taking into account this distribution time and all the equipment I have in my station, in my factory, including the forklifts, the AMR, the conveyor, etc. And here, what's happening here? We define some failure, so because it happens in the reality. So here, really, the simulation, we want to have like a realistic simulation because here we can also simulate some issue. Like missing part, failure, etc. So I can define my with my distribution time. I can define the time between failure and also the time that I will need to repair the failure. And here I can define that this failure I will have a team of worker, maintenance team to be in charge of repairing the failure. But maybe the worker will be not available, so the failure will stay for some time. This is something I want also to simulate. So now I have defined the failure. I can run again my simulation and do some what if analysis. I can maybe increase the number of workers, etc. Last video on this topic. So it's first goal of the flow simulation is to understand if I can reach my production, how many workers I need, a machine, etc. But there is also one of the goals also is also to communicate. I have my project for my new factory. I want to explain to my customer or to my partner. I want to explain, or to my management. I want to explain what I want to do. And the 3D is a great tool to communicate, especially using the 3D experience platform where we can collaborate with many people. All the people are connected to the same database and can have access to the same amount. No need to share file. And so it's also a way to explain the project you have for a new line in your factory. I think I finished on the virtual factory and especially the discrete event simulation solution. So now, Julien, maybe you want to explain what is the DELMIA solution?
Thank you, Cyrille. So at Dassault Systèmes, we are building on more than 30 years of experience in the field of robotics. And with the 3D experience, we now have the most advanced robotics solution ever to simulate and program robots, as well as doing virtual commissioning. So we offer a solution that covers most processes. It starts with material handling, or also known as pick and place. So a good example is machine tending. So here we're seeing some UR cobots loading and unloading raw material and parts from an NC machine. It could be also a press line simulation, for example. Another category which is very important is point-to-point processes, like body and white, which is spot welding for car body. So here we are seeing a typical line composed of many Kawasaki robots. And here the challenge is to ensure that there is no collision between the robot and its weld gun with the product, but also with the tooling and also between the robots together. In the same category of application, we also cover point-to-point or drilling and rifting processes, for example, which is very much used in the aerospace industry. And here we have a dedicated tool, dedicated interface for this kind of industry-specific requirements. We also cover surface processes like painting, shot peening, and polishing. Here we are seeing a painting process of a car. It's a very interesting use case because we are using what we call line tracking and rail tracking. So the robots define its trajectory based on the geometry of the product and also the movement of the product. And everything is computed in real time. And we can go as far as simulating the painting thickness on each area of the car to make sure it's meeting the product requirements. Next is contour processes. Like arc welding, sealant deposition, or roller reaming. Here we are seeing a typical arc welding cell where we program the robot synchronized with the positioner. We can also combine our DELMIA machining solution and our DELMIA robotics application because we are on the same platform to do milling operation using a robot. And we can do other type of process like engraving, drilling. And we can also do additive processes with the robot. Where we're seeing a very simple case of additive process, material deposition with a robot. And one of the, let's say, last addition is logistics processes. So of course, with processes like palletization, and we can also manage ASRS systems and AMRs. So in robotics, you will get to work with many different robot brands like Fanuc, ABB, and KUKA, but also with some emerging players, mainly from China, such as Xiaosun, Obo, Effort, or Innovance. And this diversity is a challenge because each brand is using its own unique programming language. So that's why we developed a robotic solution which can simulate robots for many brands. So, and in the same environment, you can simulate and program dozens of robots from multiple brands. And we provide quite an extensive library of more than 2,000 robots that we regularly update to make sure it includes the latest models. And we also provide OLP translator at no extra cost as part of the solution out of the box for the main robot brands. So our customers can design their product in CATIA or SolidWorks, CATIA V5 or CATIA 3D Experience, and then define their process and do their fastener planning in DELMIA Process Engineering before running their robotic simulation and doing offline programming in DELMIA Robotics. By doing this, we can much better manage products with many configurations. And it also facilitates new product introduction and change requests. So, and then of course, the main goal of robotics and OLP is when the solution is complete, you can download your program to the physical robot in the shop floor. And you can also import or upload an existing program into DELMIA Robotics to replay it or to improve it. Our solution includes some very powerful features, such as this one, so robot collision avoidance. So here we are in our spot application I was mentioning a minute ago, and our solution can automatically calculate the fastest trajectory between very complex points to ensure there is no collision and that we achieve the smallest, the most optimized cycle time. Another key aspect is that we can easily connect to the physical world. So, for example, we can connect with the virtual robot controllers. Here in this video, we're showing how we connect DELMIA Robotics to FANUC RoboGuide. So we are actually replaying a FANUC simulated program on the VRC of FANUC and replaying it back in DELMIA Robotics to ensure it's correct. By doing this, we can get the exact cycle time and trajectory of the robots, and also it makes sure that well, we save a lot of time when it's time to do the final FANUC TP programming. And of course, we can also connect to most robot brands. So this type of VRC, we can manage KUKA or ABB, for example. And we can also connect to most robot brands using RCS through RS1 standard. More and more also, we are aiming or we are integrating AI technology in our solution. So in this example, we have a point cloud of a factory that we are opening, and our solution can automatically detect the different geometries in the factory, detect that it is a robot, and facilitate the user experience so we can replace it more easily from a robot, an exact robot from our library. And I think back to you, Cyrille, on machining.
Okay, so thank you, Julien, for this update on DELMIA for robotics. So now DELMIA for machining. Again, we have mentioned that already, but the most important value of the DELMIA solution is what we call the digital continuity. What does it mean, practically speaking? It means that, for example, in machining, if I have my product here in my CAD, in CATIA, I can do my design at the engineering department. I save my product in the database in my 3D Experience server, and then my colleagues from my manufacturing engineer colleagues, they can define the process plan, so the sequence of operation to be performed to produce this part. And maybe one of the operations will be to do some machining. So then the programmer will be able to starting from the process plan to open the context at this operation, get the part to be programmed, and starting from the raw material, you will be able to do the NC program and to simulate this program. And then later, because digital quantity is not just between design and manufacturing engineering, so it's also with the shop floor, so we can then later push the program created here to the shop floor to be used by the Apriso MES and to be distributed to the NC machine. So this is what we call the digital continuity, and here it's a very simple example. I have my toolpath created in DELMIA machining on the pocket, design in CAD. Here I do a change in my in CATIA, I do a change of my pocket, and in one click I can update my trajectory. So my toolpath is always completely based on the 3D. So any change on the 3D can be replicated very easily on the DELMIA side. And it actually works in the two directions, because I can also have a problem on my machine at the shop floor. I want to change my machine. It's also something very easy here in DELMIA machine. In one click, I can replace my machine by a new machine and recreate the problem. So here what we have is the solution for the milling. So here actually it's something that was already available in CATIA V5 machining, but we have also now some new technology where we can also simulate and program mid-turn machine, turning actually and mid-turn machine. So here we have the real machine, and we see that we have this machine, and now we can do the simulation and define and define the sorry, let me go back here. we see here the part operation and the maneuver program with a different operation to be performed. We can detect the collision. We can check if we have if the machining is correct or no. And so here we have the comparison between the simulation and the real machine. Something that we mentioned already, we can also do machining with robots. And here's something interesting for mold and die, specifically the concentric milling. So we have this capacity to compute the tool path in a way that we avoid the excessive heat on the tool, and we want to save the life of the cutting tool. So we can avoid this by the concentric milling approach, where we compute the tool path in a way that we ensure the fact that we always remove the correct quantity of material, and avoiding excessive wear of the tool. Sorry. So let's continue here the video. After the machining, we also have additive, of course. So we can also simulate and program 3D printers. And something we introduced recently, it's a new application for laser and water jet cutting, where we can also do nesting. And also important in all the machining solution, all the machining role we have in DELMIA, we also have now the wire EDM capability to simulate and program this kind of machine. Okay, so the last topic will be ergonomics. So here, of course, we want to be sure that the workstation is designed correctly, and that we can have the worker will have a good posture. So we want to check if using some ergonomics rules if the posture is correct. So I start. It's actually interesting. I see we start from we are always in the 3Response platform. So we start by a search. We open the data set that the other colleagues have created with all the applications that we have seen before. And here now I am on the ergonomics application. So actually I will now be able to launch my study. And I want to check if the position of this product is correct. So I go in the ergonomics application. It's always through the compass. On the top left, there is this compass, and we select the application. So here I have to define the ergonomics task. So I have like a natural way to do that. I will say that I want to do an assembly operation with a tool or no tool. Here I have no tool. I press the button, and then the computation is in progress. And after a few seconds, I will have an automatic computation of the posture for the mannequin. And this is quite important, because in the past we used to have already an ergonomic solution in DELMIA V5, but it was actually the user was in charge of creating the posture. Here the posture will be computed automatically, and what we see also is that the posture is computed for 4 different populations, 4 different mannequin, medium male with like a medium male with percentile 50, tall one with percentile 95, and also a medium lady and a small lady percentile 5. So with these 4 mannequin, I'm sure that I will be able to manage 95% of the population. Here I can check that it's okay, and I can actually just by selecting by pressing this icon, I can check if the percentile can do the job. Oh, here I see that my lady, which is quite small, can do the job. Okay, so let's continue now with, okay, so I have prepared everything. My layout is completed. My robot and C program are created. My workstation has a good posture for the worker. But now I want to really go in production, but I want to check that not only the robot program on the NC machine program, but I want also to check the PLC program. PLC is important in manufacturing. Normally, we do always have a PLC to manage all the devices in my work cell. So I want to connect the PLC to my digital twin, to my virtual twin in DELMIA. So the PLC program will run either on the virtual PLC or either on the physical PLC, and will move not the real device on the real factory, but actually the virtual device, robots, etc., in my virtual twin. So this is the concept of virtual commissioning. The idea is really to save time when you install your line, your station at the shop floor. You are just before to go in production, so you would like to save as much as possible this time. And you can also check that some complex situation where for example, for a complex situation in terms of safety, so it's better to test this special condition virtually instead and not in the real work cell. So here what we see, we can do what we call seed, software in the loop, or hardware in the loop. So software in the loop with the virtual PLC, or hardware in the loop with the real PLC. But again, we have the PLC code is executing on the right, and we see on the left the behavior of the work cell. So here we can do it also with the real PLC. This is what we call hardware in the loop. Now, quickly, a customer testimony from a customer in Korea. So they produce this part, and they actually use our solution, the complete virtual factory solution. So let's go here. So here, this is actually the this is the virtual factory, and this is actually the real factory. So this is that because it's actually very, very similar. Here, this is the virtual, and we can check with this cobot that the cobot can do the job. Here we are now back in factory flow simulation. So let me skip this part. Of course, we can also use VR technology, and here we use factory flow simulation. So the role that I have explained before, and just after we also use robotic simulation, and of course it can work in combination. If I'm here, I see that here on the screen we have the factory flow simulation, and on the screen we have the robotic simulation to do a more detailed analysis on a specific station. Okay, so I think I have completed we don't want to go to the whole video. It was just a quick overview. If you are interested in this DELMIA solution for virtual factory, and especially the capability to create the layout and to perform a discrete event simulation, you can attend to the webinar we will give in end of September. You can enroll on the 3DS website, and there will be a 1 hour webinar dedicated to discrete event simulation. Then end of October, we give a webinar on DELMIA machining. So if you want to know everything about DELMIA to be used to simulate and program your NC machine, you can attend to this webinar. And then end of November, we have a dedicated webinar on robotics. We will cover with more details all the capability of this solution.